I'm David. I mentioned earlier on I am Chief Exec of Wireless Coverage, and also I was involved in the setup of this organisation. And I also built a wireless network up over many years, which was sold to QuickLine a couple of years ago. So I've done the tower climbing and all the hassle and all the arguing with customers and anti-5G people and all that sort of thing as well. So I can relate to a lot of the challenges that people have. And Tim can introduce himself.
Yeah, hi everyone. So I'm Tim Herbert. I'm the UK and Ireland channel manager for Siklu. So I deal with all our lovely distributors in the UK and Ireland. Please note, channel manager, not technical director. So make your questions appropriate for me. Simple, really easy would help. Thanks.
Okay, so I have an opening question. All the operators in the room, are you making enough money? Yes or no with your paddles? No, 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 no. You greedy lot. So I think that's always a challenge. You know, being able to build a network for a community, a town, a region is expensive, it's difficult, and it's difficult to make money from it as well as do a good job. So I just wanted to reflect on a little bit of my thoughts about how the industry has changed over the years, having been involved since the 90s. And if you think about general, internet take-up, so in the 90s there wasn't really any broadband. There was lots of dial-up. The disruptors were people like FreeServe, who gave away free subscription to the internet as long as you didn't mind paying a huge phone bill. And that was good. It was narrowband. It wasn't broadband. In the 2000s, there was a little bit of uptake. Broadband became launched. Somebody told me once that BT were ready to roll out fibre optics across the entire country, and then some Bert came along and said, "We found this technology called ADSL. We don't need to." So they didn't, and ADSL was a kind of a stumble in the direction of proper broadband at some point. Fixed wireless equipment was a bit rubbish. Anybody remember? Is it Alvarian? Breezewave, those kind of things, about £400 per client radio, do about 4 megabits maybe on a good day. So not terribly fast, not terribly successful. There was a couple of experimental government-funded projects. They were all a waste of money and used by BT and others to say that fixed wireless was a waste of money. In the 2010s, we saw big uplift in the demand for broadband. We saw government funding, about £2 billion was spent on the Superfast project. Most of that went to BT. Some went to a few other operators, a few in this room. The price performance of fixed wireless was improved. So Wi-Fi chipsets, MIMO chipsets, people like Ubiquiti bringing out their 2x2 MIMO was a big deal. You could do 50 megabits for not very much money, so that was pretty good at that time. And FWA it had a rural sweet spot. Longish range, 10-ish, 20-ish, 30-ish, 40-ish megabits was a big deal. It was good enough. I used to get people hugging our engineers for giving them 10 megabits of internet in the rural bits of Lancashire and so on, and that was pretty good back in the day. But of course, things have moved on. In the 2020s, demand going up and up and up and up, as we all know. I don't think it's going up at the same level that some people were forecasting, like Cisco. Everybody was using Cisco's forecasts 6 years ago, saying compound aggregate growth of about 13% or 16% per year, which means that we should all be consuming multi-gigabits now, I think. Gigabit funding has accelerated, lots and lots of rural overbuild. The Superfast project overbuilt lots and lots of stuff, and lots of our networks and our customers were being nibbled away at. So what was rural sweet spot for fixed wireless is becoming tougher and tougher with more and more competition. And we have to do a good job by customer service and other things, or drop prices and whatever, so that's tricky. We're also seeing lots of fibre altnets over this last few years, billions of pounds raised against spreadsheets that say how easy it is to build a fibre optic network and pass 10 million addresses. The reality is not quite so easy as that, and as a result of that, A, they've eroded some of the fixed wireless market, but B, they're all under pressure now. They're all in the headlights from their investors who said, yeah, you showed me a spreadsheet 2 years ago, said that this was easy, should be up and running by now. Not always the case. And generally, we built rural networks like this. We'd go somewhere where we could get a bit of cheap backhaul, so a town. put a dish on a tower, beam that out into the countryside somewhere or the nearest business park, and then spread it around. So you might spread out in different directions away from these urban locations where it's cheap to buy backhaul, and then sell locally in those areas. So that was outward facing from POPs. That's how I see conventional FWA networks operating historically. But it's changed a lot. Both fiber technology and wireless technology both massively increased. Fiber with XG-PON and so on, 10 gigabits and beyond. There are already trials starting in the UK with 10 gig and 25 gig on fiber. Wi-Fi 6 has been a big deal to make the last inch connectivity, the actual device, a lot easier, a lot faster, more reliable, more resilient. And Wi-Fi 7 is ready to go. I think we're going to have an exclusive bit of information about Wi-Fi 7 tomorrow from one of our good partners. We're seeing maturing of E-band and V-band. So E-band is 80 gigahertz-ish, V-band is 60 gigahertz-ish area, and newer chipsets coming along, which gives access to bigger chunks of spectrum, faster speeds, and all that kind of stuff. And one of the big things that is changing and has changed is now urban fixed wireless is viable. Historically, if you pointed your 50 meg capable access points into the middle of a city, 50 megs these days is no big deal, and you're in a competitive landscape. There's ADSL, VDSL, and fiber optic. So it's never really been that interesting to point a fixed wireless network into an urban area. That's changed now. So the urban opportunity, I think, has come around from a couple of things. Firstly, the fiber altnets are all struggling. I don't know any that is ahead of their connected premises passed or premises connected. I saw an operator proudly announcing that they've passed 100,000 homes now with fiber, and 10,000 of them have actually bought the service. 10% take-up. I'd be ashamed of that. I think that's pathetic. When I was building networks, we would expect to see 40, 50, 60, 80, even 90% take-up. And it's not something to brag about, but in that world, it seems that 10% is a big deal. I personally am unimpressed. Fiber builds are hard, and we're also seeing a couple of operators who started off with fixed wireless, who raised money, went into fiber, now starting to re-energize their wireless networks, because it's a lot easier to get numbers on the board to show the number of premises passed. So people like Airband, people like County Broadband have started to reinvigorate their wireless networks. We're seeing fixed line altnet providers now starting to open their eyes to fixed wireless, and there's going to be some pretty big names I think we're going to see in the press over this year who have been very active in the fiber network market, now doing stuff with fixed wireless, which is good. In the meantime, 60 gigahertz stuff and meshing actually works. A lot of people tried maybe the first couple of iterations or the first release of pilot kit using Terragraph. It was a bit underwhelming. Let's say the Siklu stuff was good in some areas, not quite so good in other areas. The Cambium stuff was good in other areas, not so good in some areas. They've had a couple of years now to get that right. The supply chain has now been improved. The availability of equipment, the maturing of the software that runs on the Qualcomm chips and so on is a lot better post-COVID and all that sort of thing. So, and there's a lot of people in the 60 gigahertz space, and there's a lot of experience and a lot of expertise from some quite familiar names now. So I'd like to hand over to Tim to talk about some of the real-life projects.
Thanks, David. Before we go on, first things first, can I just get you to get your lovely little paddles out for me? And can we just have a show to see who's currently using 60 gigahertz in their networks? Oh, a lot of green. We love to see that. Okay, of those people, who is using 60 gigahertz point-to-multipoint? Oh, still lots of greens. And how many people are using Terragraph solutions? Okay, slightly less. All right, well, that's great. So, yeah, as David was explaining, there's been a lot of change within the kind of urban landscape over recent years, and we're seeing a lot of the traditional full fibre providers moving to hybrid wireless fibre models, just where trenching fibre can be It's super expensive, it can take ages to get in the ground, and actually it results in really poor levels of service to your customers. So we're seeing much, much more of that hybrid wireless fibre approach. I just want to go through a couple of little case studies of maybe some of the more weird and wonderful examples of what people are doing to monetize their networks. So the example we've got here is a neutral host network in central London. Now, this WISP managed to get concession to all of the street furniture in 3 or 4 different London boroughs. So if you go out into central London this afternoon from Trafalgar Square to Marble Arch, look up, you will see Siklu Telegraph on probably every other lamppost. So they've got this concession, and with that concession, they get exclusivity. Wireless access, exclusivity to those lampposts. So nobody else can deploy wireless kit on those lampposts. From that, they do public access Wi-Fi, free public access, which was what they used to get the council interested, to get them in. From that, they are then mining customer data when they're onboarding customers onto their access Wi-Fi, and they are using that for retail analytics. They're using it for footfall data. They're using it for a whole host of other applications. But really, that's a very small part of what they're doing and why they're doing it. The reason that they've now done this is because it means that any IoT devices that get added in any area, they are the surefire bet to connect it. We can't go running a cable every time some new piece of IoT technology comes out that requires connectivity. It also means that for small cell networking, as 5G starts to grow inevitably and the MNOs start to realize that they need to increase their network footprint across major cities, and this is a major city example, but it also applies to small towns, this customer has the infrastructure in place. It's in place, it's on the lamppost, and no one else can have it. So when Vodafone, Telefonica, whomever it may be, decide that they need to increase that footprint, these guys are the obvious choice because the infrastructure is already in place. And that is for anything else. We also, so similar to this, in other examples, CCTV networking is a huge, huge thing for us. Some of you may recognize the lovely John Tarleton, who was very excited to find a Siklu radio in the wild. We were out after a couple of beers and we spotted one. He was very happy about it. But in this example, we're using it for CCTV backhauling. Now, the really key thing with this is that generally CCTV integrators have little or no understanding of fixed wireless access. They need to be engaging with people like you, because they don't understand wireless. It is a dark art to them. They understand that it's necessary. They understand that it is a key part of building a citywide CCTV network, but they don't understand how it works. So it's all the more important that they engage with partners like you, who do have all of that experience and expertise, to be able to deploy these rock-solid networks. And then, again, you've already got access to the street furniture, any and all IoT applications, a new business that comes up that wants connectivity, all of those things where fibre is going to take a long time or cost a load of money to connect, you can connect next day. And really, in terms of scalability, it's limitless. So you can have huge density of devices, you can scale very, very quickly and very, very widely. It is a very quick way of getting gigabit connectivity to hundreds of devices. And then another part of that is temporary event connectivity. So as a wireless ISP who has got a network that spans a town, a city, or wherever you've got it, when, in this case it's Southampton Marina, decide they need to do an event, well, who am I going to talk to? I'm going to talk to the people that have got the infrastructure all around me, because actually Southampton Marina, boat show, whatever it is, it's really not going to be much of a job for me to put 2 radios up, get connectivity into your event, and then distribute out with Telegraph. We can connect as many different stalls, stands, whatever, with gigabit, rock-solid connectivity, and you can take it down and use it again elsewhere. So, for many, many years, people have looked at fibre as the asset in the ground. The great thing is that with modern 60 gigahertz technology, you've now got an asset in the air. And the great thing about the asset being in the air rather than under the ground is, if you don't need it anymore, you can take it away and redeploy it elsewhere. So by sweating those assets, you can get connectivity options and resell that product over and over and over again. So I'm actually going to hand it to David now, who's going to talk some more about how you can make some more money out of all this, because that's what we're all here for.
Thank you. Yeah, so it seems to me that there's an enormous amount of capability in this room and amongst our community. We kind of take for granted what's involved in going to somewhere high, installing some equipment, laying some power, getting backhaul. Imagine somebody who's not done that before trying to get into this space. It's quite tough. if you've only ever worked with, let's say, fiber optic cables or whatever, or coax, learning how to do that is actually quite challenging. You've got those skills. You know what it takes to safely plan and build a wireless network. So there's opportunities to redirect your networks inwards. So rather than just building out into more and more rural places and getting more and more nibbled away, what would happen if you got your pops and instead of aiming outwards, you aim back into the town that you've just popped from? How many customers might you pick up if suddenly you had a 1 gigabit or multi-gigabit proposition to offer them, which you didn't have previously? Suddenly you've got a competitive service to offer to people in and around your existing infrastructure, so you don't necessarily need to build a lot more. And you could also help people who want to build these networks. So some of the alternative network providers, the guys that I meet now and again at Inca events, for example, typically the guys that raise money to build fixed fiber networks, they would be happy to look at this, but they're scared of it. In the same way that we, a lot of us, and I went through this myself, don't really understand how to embrace fiber properly. It's a different skill set, different equipment. Then the same applies to some of these fiber operators. And WISDM is an example of a tool that can help you identify opportunity. So what I wanted to do, if anyone is up for this, is to say to everybody in the room, if you want, we will, for free, show you how many properties you could connect on gigabit connectivity simply by adding a 60 gigahertz access point where your existing infrastructure is. So you might have 10 access point sites, you might have 1,000. I would be very happy to give you a list of the UPRNs that you could connect if you had the ability to, if you did put on some 60 gigs equipment. And I think you'd be quite surprised by that. When I've done analysis for other operators, suddenly you can find 1,000, 2,000 potential properties that you could connect at gigabit services that you wouldn't have connected before, using your existing skills, using your existing sites, your existing backhaul, but adding a new radio. And if that brings in more revenue, you can then add more radios if you choose. So one challenge, does anybody want to give me a location, and we'll just put a pin on a map and we'll test it, and you'll see an example. Anybody got any offers? If not, I will make one up. There's one at the back.
Hold on. I'm going. It's the comedy running up and down the room.
It's very amusing, thank you. I don't know if you've got access to my network already on WISDM, David.
Yeah,
all
I wasn't planning to share your network, but I can drop a pin somewhere, anywhere in the UK.
Just somewhere on the Isle of Wight then, Newport Isle of Wight. Which is down.
Oh, that Isle of Wight.
That Isle of Wight.
Somewhere near Newport.
Postcode search, can you do
Well, I can do that if you want.
PO31 1XP? PO301 XP, sorry.
Okay, so if I grab my pin and drop it somewhere around there, let's pop it on a building. And I've got one omnidirectional antenna on 62 gigahertz. And if I test the coverage, this will do line of sight tests to all the properties that could get gigabit connectivity. So we're going up to here up to 0.5 kilometer. We could reduce that. And what that shows is that you would be able to connect 78 properties off that building. There would be 478 that wouldn't connect because of line of sight. So if I just grab one of these at random, here's a green dot, we can see that this would get connectivity. We're skimming across the roofs of some other buildings. And if I zoom in a bit, we can see that actually on that building, this place here on that building would get a signal. These places wouldn't. So when you send an engineer out, you know where to tell them to put the ladder up and put the receiver up. Okay. So if you imagine 78 people in that area that instantly you could offer service to, and you could get their addresses, which you're a Wisdom user already, you know how to do this. You could drop them a postcard and say, great news, guys, before the fiber build-out happens in your area, we're already there. Gigabit connectivity, 35 quid a month, sign up now. So multiply that out, you can see what the revenue would be on that. Anybody else want to challenge me?
Hold on, here we go. Hold on, where are we going? Did someone have their hand up over there as well?
Go for our office, MK181RQ. We've got Swish Fibre and Gigabit round the corner, but not quite there yet.
Okay, so that's your head office building, hopefully. That looks familiar to you. Well, sorry, that's the centre of the postcode, isn't it?
MK181RQ.
Oh, I put 1LQ, I apologise.
That's right.
You can never type when someone's looking over your shoulder.
That's better. Pretty much where that pin is where our antenna is.
So let me just test how tall that building is. So that building is only 6 metres above the ground, so it's not a super tall one. That's good. So if I drop an access point on there, there's my access point. I'll put it at 10 metres. I'll put it on 61 gigs.
And would that be the Siklu N366?
This is assuming isotropic, but I can specify that I want an N366. So there's the beam pattern for that. So that's quite a good spot by the looks of it. That would give you 144 possible connections from that point. 330 would be in range, but wouldn't meet your sort of gigabit criteria. So, and then from here you can zoom in, you can download the addresses for those. So that gives you your marketing base. So you test it before you buy any kit.
Yeah.
Okay. So, do you want to do another one? You'll get slightly.
Hold on. The room didn't hear that.
What happens if you put in 67 gig, so channel 5 or channel 6?
You'll get a slightly different result. So, yeah.
Thanks, Dave.
Next you'll be saying, what if it was 67.125? So yeah, it does affect the propagation depending on the frequency. Obviously the losses and the propagation characteristics are different. So I think that's enough to sort of prove the point here. Our offer is if anybody would like to see what's possible across their entire network, then we'll be willing to sample that for you and give you a full view on the potential coverage running if you were able to provide gigabit coverage. So, any questions?
Hold on. I'm running. It's comedy tripping over Tim's leg.
Thank you. Okay. Wincom Technologies work with you guys, with Siklu, work with Cambium guys, with Intracon, a lot of vendors, okay? And we know pretty well how these solutions and these vendors works in every environment and in order to meet the customer needs. It's a pretty, amazing solution, okay, the platform to simulate the links, but I would like to, if you could offer, exercise of truth. Okay, so you have been talking about Siklu, you have been talking about Cambium, even MikroTik or Ubiquiti. Could you show us, the performance of Ubiquiti or MikroTik with the same locations that teammates are provided? Because we know that the performance and the behavior of these solutions depends on the vendors and if they work with under Telegraph protocol or not. So I will appreciate that kind of in order to show everybody why we are talking about Telegraph or why not. Thank you.
It's a good point. The characteristics of the equipment, even though they share the same band, it changes a lot. They don't all use the same chipsets. Telegraph is a great standard, but there are others which also have advantages. So for Wisdom, we're happy to model any. Today's offer, I'm sitting side by side with Siklu, so this offer is something that we're doing with Siklu, but that doesn't mean that we can't work with other vendors. What I don't propose to do is to show to people what the coverage would be and how it would differ if you were to buy this equipment or this equipment or this equipment. In this case, we'll profile it based on Siklu, and that may well be enough for somebody to be persuaded to buy some Siklu. If they don't want to buy Siklu, if they have a policy of buying something else, then we can have a separate conversation with them. But I'm not trying to set out a benchmark that says one is better than the other. They are all different, and there are advantages from each type. Siklu has kind of 4 sectors aiming in 4 different directions. Cambium's Terragraph product is very different. It's kind of got 270 degrees. That has advantages in certain settings. WeLink works in a different way. Adtran's product, it's different chipset, easier to mesh, range differences. So yeah, that's really detail when somebody wants to get into what kind of product that they would choose.
Dave, question then. What's your level of accuracy that you're predicting when we came up with those numbers with the green dots?
Well, in that example, we're using height data for all of Great Britain. So kind of we know how high the ground is and how high the buildings and trees are at 52 billion locations in the UK. So basically every 2 meters in every direction, we know if something is above ground. 2 meter resolution data means that we typically get about 95+% accuracy, to the point where it matters where you install it on the building.
And so, to kind of illustrate Carlos's question a little bit, if you're saying we've got 95% accuracy in what we're reporting, would that be the same across the different vendors as well?
Yeah, the accuracy is really a product of the data in WISDM that's used to calculate it. And we can put higher precision data in, but we tend not to go into super high precision because if you design a network that is optimized at 12 centimeters resolution, that's great. As a former sort of ladder climber and tower climber, it's hard for me, in my experience, to mount stuff to within 12.5 centimeters of what the design says. Because the world is in the way. You can't just screw anything anywhere. You have to adapt. So we tend to find that you don't get any value by trying higher precision in most cases. There are certain exceptions to that.
Great. Any more questions from the floor?
So I just have one idea about this. Our TPC Link provides a portfolio that supports this solution that to deliver the Wi-Fi coverage to customer as with your products as to get the internet, and our products our internet portfolio and our Omada products provides the Wi-Fi coverage to the customers. And we can support this. If you have any query or you are interested in this, and we are happy to talk about this. And our table is outside.
Yeah, thanks for that point. I think the point, as I understand it, there is that if we deliver gigabit services to our customers, that's great. But you need to be able to then distribute that within the home. So it does bring in the challenge. You need good routers and good Wi-Fi and so on as well. I think that's a very good point. Thank you. Last show then. Who wants one? Who would like to take us up on this offer?
Green cards for Res.
Green cards.
Come on, lots of green cards, please.
Yeah, thanks Cambium who don't want to do it. That's fine. Okay, please get in touch with Tim or I about any follow-up with that. Thank you very much indeed. Thank you very much for your time.
Take for one more question.
Absolutely.
Just for my clarity, the green dots, the clear line of sight was all point to multi-point, direct back to the sector, so there was no meshing involved. Okay, but if I understand the Terragraph product will mesh also.
Yeah, so all I'm showing there is if for example, operators got their existing infrastructure, added one radio, one point to multi-point radio, what could you do with it? So minimum investment, how do you maximize a return? But absolutely, one of the strengths of many of the vendors' 60 gigahertz products is that they do mesh. Telegraph is a meshing protocol, but there are others as well. So Adtran, for example, their product is brilliant at meshing as well.
Yep.
It's probably the easiest to mesh, to be honest.
Yeah, and I can understand the application in urban areas on street furniture. If you look at meshing in a more rural or even suburban area, you might not have access to street furniture, so you're pushed towards meshing through residential properties. How do you cope with the power issues in those situations? How do you guarantee power is always available in that?
Okay. Yeah, so using customer premises equipment, using customer premises as access points does bring hazards, and I speak with experience here. You say to the homeowner, I'm going to put some kit on your roof, do you mind leaving the power on? And then they bugger off on holiday.
Correct, absolutely.
And switch everything off, because why wouldn't they?
100% seen it.
Yeah, so that is an important factor. Using street furniture and public sector assets is good, so if you can use libraries and public buildings and the government, it has a policy right now which says every local authority must make their public sector assets, including libraries, town halls, all that kind of stuff, more available for wireless, high-speed wireless services. If you're going to use residential properties, make sure you've got the right wayleave with the property, make sure that the customer understands, and make sure you've got a mesh. Because the good thing about a mesh is that it will heal itself, and if a subscriber unit needs to jump from one access point to another, generally that will happen automatically.
Okay, thanks.